Hey class, this is Mr. G. So we're continuing on with algebra. We're on section 1.8. All right, we went ahead and did example 1 and example 2 yesterday. If you want to see those are in the previous video. Okay, but just to review those real quickly. So we found a couple of characteristics in a graph. Okay, for example 1 and example 2, we found out, we were finding out if it's linear or non-linear, if it's a line or if it's something else than a line. So that's what we figured out on these two. Okay, this is non-linear, this is linear. And then on top of that, we also found out where they cross the x-axis and where they cross the y-axis. So the x-axis, where it crosses the x-axis, it's called the x-intercept. Where it crosses the y-axis, it's called the y-intercept. Okay, and we found out when it's an x-intercept, okay, y is always 0. When it's the y-intercept, x is always 0. Okay, we did that on another video, so if you haven't seen that one, go ahead and check that one out. All right, so let's continue on to example number 3 and seeing some characteristics of graphs. So here's example number 3. So we have an object, the height of a launched object. So it looks like somebody launched an object from the ground. So this could be a rocket, one of those that you put, stomp your feet and it launches up. Okay, so it looks like it was launched, and then it went up 60 meters, and then it came back down. And it looked like from the beginning to the end, it took about 7 seconds. Okay, so that's interpreting this graph. So let's go on to actually reading what the question is or what we're going to do today. A graph possesses blank in the y-axis or some other vertical line if each half of the graph on either side of the line matches exactly. So this means that a graph possesses line symmetry in the y-axis or some other vertical line if each half of the graph on either side of the line matches exactly. So if you look at this graph right here, it looks like if we draw some vertical line down the middle, it looks like the left side and the right side are going to be the same. Let's do that now. I'm going to use my handy dandy ruler. Okay. If you have one, go ahead and use one. I'm going to put it right there. Right. It looks like it's right in the middle there. So I'm going to go ahead and draw a line straight down right there. Okay, let me erase it. So there's my line. Okay, it looks like the left side and the right side are exactly the same, correct? All right, so this graph has a line symmetry. Okay, it is symmetrical. It is the left side is exactly the same as the right side. Okay, so we would state it like this: line of symmetry for this graph is at x equals, it looks like it's 3.5. At x equals 3.5 seconds. Okay? Now, this is what this means. This means that this object was launched in the air, and it took the same amount of time to go up, and it took the same amount of time to come down. So it took 3.5 seconds to go up 60 feet, and then it took 3.5 seconds to come down 60 feet. So a total of 7 seconds in the air before it fell back to the ground. Now, this is just an illustration. Okay, in the real world, this doesn't happen. Okay, some objects, when you get to physics and all that, some objects, depending on the mass, go up a certain velocity or a certain amount, and then they come down a certain velocity. So either they're accelerating or not accelerating. So this is just for illustration purposes. Okay, so in this case, this graph has a line of symmetry at x equals 3.5 seconds. Okay, that's what this means. Now let's go ahead and go on to example number 4. Example number 4. Let me erase this one because the line moved. Okay, so example number 4, we have 4 graphs. So let's get some characteristics of these 4 graphs. Okay, first of all, this graph right here, is it linear or nonlinear? Okay, this is nonlinear, right? What about this one? Linear or nonlinear? Nonlinear. And then the last one, it is linear. Okay? We have the first characteristic of these 3 graphs. Okay? The y-intercept. Where does this cross the y-intercept? So where does it cross the y-axis here? Okay? It crosses the y-axis at this one. It's going up by 80. Okay, so it's 80, 160. It keeps going up. So it looks like it crosses that at 640. So this is 640. So your y-intercept has 0, 640. Oops. 640 feet. Okay, and the x-intercept is, where does it cross the x-axis? It looks like it crosses the x-axis at 2 places. Okay, it crosses at 2 places, so it looks like it's going up by 80 again. So it goes 80, 160, 240. So it looks like it's 320. It crosses the x-axis at 320 here and at negative 320 here. So negative 320, 0, and then the other one is 320, 0. And then let's look at the line of symmetry. Where does this split it in half? It looks like it splits it in half at 0. So the line of symmetry is at y equals 0. Okay? Next one. The y-intercept. Where does this one cross the y-axis? Okay. And it looks like it crosses the y-axis based on, you can look at your paper, but we're going to agree on a consensus, more or less, where it crosses. Okay. So it looks like it crosses on the negative side, right? So it looks like it's by 4s. So it looks like it's in the middle. So it's at 0, negative 6. 0, negative 6. And it's feet. And then the x-intercept is where it crosses the x-axis. It looks like it crosses the x-axis here and here. Okay, we'll agree on a consensus of where it crosses. So it looks like it crosses at 13. 13, because this is 12, it's a little past it, so let's agree on 13. So it's at 13, 0, and also on the other side, it looks like it's negative 13, 0. Okay? And then the line of symmetry, again, it looks like it's the y-axis, so y equals 0. And then our last one, y-intercept. So the y-intercept is, look, where does it cross the y-axis? So it looks like it's a little bit above 240. So it's going to be, let's put 0 to 50. And the x-intercept, it looks like it's right there. So it looks like it's going up 2, 4, 6, 8, 10. So it's going to be 10, 0. And the line of symmetry is none. It is not symmetrical. Okay? The left side is not the same as the right side. In this case, yes. You block this. This is the same as that. Right here, this is the same as that. There's no way you can't. There's no way you can do that one. So it's line of symmetry. Now, to explain these a little further, let me explain these real quickly, what this means. So in this case, we have a gateway arch. Okay, the gateway arch is a building. It's a big building over there in Missouri. So in this case, the highest part of this gateway arch is 640 feet. So if you were to measure the left side and the right side, they're exactly the same. Okay, you could actually build it in two and connect it right at the end like that. Okay, this one, it's a solar reflector. So again, these reflect the sun. They could be used as to power up buildings. So this is facing the sun and the rays are hitting it. That's what this is. Okay, and then this one, it's the whale population. So when they started this study since 2007, which is year zero is 2007. In 2007, there was about 250 whales, and now 10 years later, which is 2017, okay, they're dramatically decreasing in amounts. That's what that means. Okay, they're always decreasing, always decreasing. All right, guys. So there it is. There's example 3 and example 4. So we dealt with line of symmetry today. Okay, and then we also saw these characteristics on these graphs. Is it linear, nonlinear? Give me the x and the y intercepts. Okay, and also with the line of symmetry. So you're gonna get a quiz on this here shortly, and we'll go from there. All right, guys.